So I'm going to be doing my presentation on Chernobyl, the world's worst nuclear accident. Um, let's hope it stays that way and doesn't get outdone by something else. So the reactor complex was originally started to be built in the 1970s, and the final reactor came online in 1983. So they built this facility pretty fast. Officially, it was called the Vladimir Lenin nuclear power plant, and it consisted of 4 RBMK reactors with a thermal capacity of 3,200 megawatts and a power generation capacity of 4,000 megawatts. It produced about 10% of Ukraine's electricity at the time that the accident happened, and the nearby city of Pripyat was there to house the workers and the families that worked there at the plant. It was about 3 kilometers away. There were 2 more reactors that were about half complete at the time, reactors units 5 and 6. They were the same, they were RBMK 1000s as well. So they were the same reactors as units 1 through 4. Reactor 1 previously had actually had a meltdown that had a significant release in 1982. So they kind of kept this release on the down low. It released like radioactive gases, which eventually actually kind of rained down due to a storm on Pripyat with contamination. So they kind of kept it on the DL. They just basically told residents stay inside for, I think it was 2 or 3 days. And then they went and just kind of sprayed a solution, washed things down, and called it good. Like they didn't even really tell them what it was really about. So there's a picture right there. You have Unit 1 right there, Unit 2, Unit 3, and then Unit 4 that had the accident right there on the end. Events kind of surrounding that kind of started the chain reaction, I guess you could say. Reactor 4 needed to have a safety test done of all things. They failed to complete the safety test several times before, and they were determined to complete it. They were supposed to have actually completed it before licensing this reactor there and actually getting it up and running, but due to demand for electricity and them wanting to be able to produce, they just kind of shoved it underneath the table and we're like, we'll just get it done later. You'll get it done. So the test originally was slated to be done during the day with the day crew, which had been the ones that had originally run the test the previous times. The night shift had never ever been trained on it. They actually really had never even heard exactly what it was about. So it had to be put off later due to electrical demand. There's actually another facility that suffered a failure, and so they had to, a grid controller called them and said, no, you can't do the test, we need you to keep producing electricity. The test was there to ensure that there was enough cooling from the pumps as the turbine was running down, if there was a total station blackout before the backup diesel generators kicked in. So essentially they wanted to see, could the electricity coming from the turbine be enough to run the pumps long enough for the turbine or the generator to kick in, and that was approximately 45 to 50 seconds. And conditions were not right. The reactor had been running for several hours at 50% power, and so it had built up xenon, and so it was kind of, and they had to take it down to a low power level, so it just wasn't, the original thing was it was supposed to be run between 90 and 100% power previous to the test. That way there was good equilibrium and good burnup of xenon. The day shift had been, so they actually were preparing the reactor for it, so they took all the safety systems offline, emergency core cooling, for example, and the day shift had been running the reactor that way without safety systems in place for several hours. So there's just like a picture of the control room previous, and then there's a picture of the reactor later. So the night shift came on, and right as they got into the control room, they were informed that there were going to be doing a test right as they arrived. The night shift operators never performed this test, and were told they had 5 minutes to review the procedure and figure it out and be ready to go. So they proceed with the test and tried to lower the power to 700 megawatts to start the rundown. And it was briefly at 700. They got it there. They're like, okay, we're ready to go. And then power started falling rapidly with no operator input whatsoever. The reactors then switched into manual control in effort to try and bring the power back up. And power almost immediately at that point went right down to 30 megawatts due to xenon poisoning. Operators that were there didn't want to finish the test, but were forced to by their supervising operator, Dyatlov. So there's an actual picture of Dyatlov, and then that was the guy that played it in the HBO series. Operators they were ordered to and basically threatened with their jobs, and also to be essentially investigated by the KGB. So that they, out of fear, continued and tried to bring the reactor power up by withdrawing almost all the control rods. There was only 12 of the 211 that were in the core at the time of the accident. They were only able to get the reactor up to 200 megawatts with all those withdrawn. And again, they tried to stop the test, but were reprimanded heavily. They kind of just gave up and hope for the best. The test continued and steam supply of the turbine was cut off. And as the turbine winded down, the pump slowed and steam voids due to energy in the core, and the heat started to form. This intensified the nuclear chain reaction, and the reactor power started to run away, and power started to skyrocket. This is due to the positive void coefficient that is in RBMK reactors. So as temperature goes up, reactivity also increases instead of going back down, like reactors here in America. AZ5 or scram was pushed right at the last second. They saw it was starting to run away. They're like, okay, we'll just hit scram. They pushed that, but operators didn't know that the control rods were graphite tipped. Well, graphite's a moderator, so it increased power sharply for a minute. As there had been so many steam voids in the core, and reactor power is running away so fast, going up 10 times within less than a second. So the quickly accelerating reaction, it created so much heat that the fuel rod channels fractured, which then jammed the graphite control rods about a third of the way in, so the tips were in the core, thus pretty much endlessly accelerating the reaction. So it led to a rapid increase in steam pressure. This blew the reactor top off, exposing the superheated graphite to the air, where it started to burn, as well as a secondary explosion that occurred right after due to hydrogen gas, that they're pretty much almost certain that it was due to the steam reacting with the zircaloy cladding on the fuel rods. So it caused things to even explode worse than just the steam explosion. This behavior with the control rod spiking power had actually been observed before in an RBMK reactor, underneath kind of similar conditions, but they were at a lot lower power, and so they were able to shut it down safely and didn't have a major accident. But it was kept as a state secret by the government, so the operators didn't know, and even Dyatlov actually didn't even know that this was going to be a problem, because they thought that there was always going to be that failsafe or scram or AZ5, that if it got to that point that they could just shut it down. So reactor power peaked at about 30,000 megawatts, or about 10 times its normal full operating capacity. When the second hydrogen explosion occurred, it dispersed the core, so that stopped the chain reaction, so at least that was good. But it also blew everything around and graphite and everything out of the core a lot worse than even the steam explosion. It was observed by a power station employee that when they looked out, they saw the top of the reactor 4 blown off, and a blue glow that looked like it was going up into infinity, up into the sky, coming out of the reactor. The explosion and then the subsequent fire started spewing radioactive material out into the atmosphere, like highly radioactive material, and just a lot of it. The chief of the night shift for Reactor 3 actually wanted to like shut down and scram his reactor and get all his workers to safety, but the chief engineer would not, or the plant controller would actually not allow this, and gave operators respirators and iodine tablets and told them to continue working and continue running the reactor. We're going to go to a video. Maybe.
Steam turbines were located in the adjacent turbine hall. Unit 4 had been...
There we go.
This is a visual illustration of the inner workings of the reactor and the key events of the Chernobyl disaster. The power plant had 4 nuclear reactors brought online over 6 years. Steam turbines were located in the adjacent turbine hall. Unit 4 had been making electricity for 3 years at the time of disaster in 1986. The reactor was the RBMK-1000 type, 1960s design and a legacy of the nuclear power race, where trying to be first meant undesirable shortcuts were made. Technological best practices and good ideas were not shared across the Iron Curtain, and Chernobyl paid the price. The propaganda was that it was a safe reactor and that could not explode, which gave a false sense of security. The uranium fuel was only slightly enriched, resulting in a much larger reactor core. Western reactors are stable by design. As they heat up, the nuclear reaction slows, which is what you want. Chernobyl was the opposite, where increased heat accelerated the reaction, setting it up to run away with itself. The technical term is positive void coefficient. The pumps and steam systems which fed the turbines were paired on either side and circulated enough coolant water to prevent overheating of the fuel. The radioactive fuel was enclosed in a steel drum with a top and bottom lid. This was the radiation shielding which safeguarded the plant workers. Almost 2,000 vertical channels were arranged inside graphite bricks. Graphite was a favored material for sustaining a nuclear chain reaction in low-grade uranium. These channels contained the uranium fuel assemblies and the control rods. The uranium pellets shown here in red were stuck inside sealed tubes. They heated the water, which turned the turbines to produce electricity. 10% of the channels held control rods shown here in green. Moving them in and out of the core did the job of the brakes and accelerator of the reactor. The RBMK core was huge. This is the relative size of the Fukushima core, which is 17 times smaller. Chernobyl had rudimentary containment. Here it is compared to the Japanese Fukushima reactor housing to the same scale. Fukushima had 3 containment layers: the pressure vessel, a steel lining, and the outer concrete layer. The Chernobyl reactor had just the one layer. The reactor was serviced from the reactor hall above. Refueling could be done while the plant was at full power. This is a unique and big advantage of the RBMK design, but was only possible because there was no pressure vessel. This can be likened to driving without a seatbelt, which is convenient but not wise. Western reactors may only be refueled during a reactor shutdown. Chernobyl would not have been licensed in the West. The control room is located outside the reactor building in the lower levels of the turbine hall. It was accessed from the golden corridor that connected all units and was 600 meters long. It is ironic that this reactor blew up while testing if the reactor was safe. The control staff were under pressure to get the test done because the next chance for the test would be in a year. It is unthinkable that activating the emergency shutdown detonated this explosion. A design quirk meant the shutdown mechanism briefly spiked the reaction before slowing it. In certain operating configurations, this is enough to send the reactor supercritical in seconds. The design fault in the AZ-5 shutdown system was not communicated to the Chernobyl controllers. The chief engineer, who had poor knowledge of reactor science, recklessly bypassed multiple automated safety systems. Vast amounts of radiation were released directly into the atmosphere. Radioactive fuel debris lay strewn all around the site. Large areas of Belarus and Ukraine were made uninhabitable. The finest radiation was carried much further and detected in low amounts across Europe, causing widespread fear and panic. The reactor lid, which weighed 1,000 tons, was blown up through the roof and landed back in the reactor pit on its side. To seal the radiation outflow to the outside world, an emergency concrete and steel cover was built in a hurry in just 200 days.
Alright, so we're going to go back to presentation. So there's a picture, kind of like you saw in the animation, of the reactor exploded. So now that the reactor had exploded, and set burning graphite everywhere, they first had to contain the fire. To make matters worse, the roofs of the adjacent buildings were actually made from a combustible material. Another thing that is strictly against code here in America. So firefighters arrived at approximately 1:45 a.m. And started to fight the blaze. The firefighters really didn't know that the fire was radioactive at all, and were just told it was an electrical fire by their leaders there. Some of them had later said, like, yeah, we're pretty sure that it had something, it was pretty bad by the look of it, and the weird, like, metallic taste that we had in our mouth and things like that. But they all said that their supervisors were all, and their leaders were all telling them that, oh, it's just an electrical fire, that's it. So the radiation levels around the fire or approximately 20,000 R per hour. So the fire was surrounding the reactor. The fire surrounding the reactor were extinguished by about 5 a.m., but the core reactor 4 was still burning and continued to burn up until May 10th. In order to try and seal some of the radioactive releases, as well as to try and smother the fire in the core, they brought in 5,000 tons of clay, lead, sand, and boron, and dropped that onto the burning core from helicopters. And these pilots pretty much were told there's a high chance that you're going to die because of the radiation exposure. But a lot of them were like, well, we have to do it. We got to get it done, and just got in and did it. So there's a picture of some of the firemen. The nearby town of Pripyat was not evacuated until about 36 hours after the explosion, due to the government wanting to keep panic down to a minimum, as well as the leaders there were misguided by plant officials saying that radiation levels were only at about 3.6 R per hour. What they failed to mention is that the dosimeters that they had only went up to 3.6 R per hour, and their high level dosimeter, which only went up, was actually broken. Then they brought in another one that was reading 15,000 in the adjacent building, and they thought, oh, it's just busted. That's why it's reading that high. It's out of calibration or something. So they thought that the danger was a lot less than what it is. That's part of the reason why they didn't evacuate as quickly. Residents were just told when they were evacuated that it was only going to be short term and that they should just grab like their important papers and some food and go get on the bus. The original evacuation zone was just 3 kilometers, or basically the town of Pripyat, and then was later expanded the next day to 10 kilometers, and again the next day to 30 kilometers, where it has remained, that they call the exclusion zone now. In all, nearly 200,000 people were evacuated from the area. So there's a picture of Pripyat before everything went down. The Soviet Union tried to keep the disaster a secret, but on April 28th, the Forsmark nuclear power plant in Sweden, over 1,000 kilometers away, had their radiation alarm set off. They determined it wasn't theirs, took some samples and analyzed that they probably had come from the Soviet Union. So they called them up, and the Soviet Union originally denied that they had even had an accident. But when threatened to have the IAEA come and investigate, they admitted that a minor accident had occurred and that they had it under total control and that it wasn't a problem. So after the fire they had gotten the fire out and put all the boron mix on it, they realized that it was all, yes, it had kind of stifled some of the releases and calmed down the fire and put that out, but now the decay heat from the material was actually causing all the mix of the boron, lead, sand, everything like that, including the fuel, to actually melt together and form a radioactive lava. And it was headed for the boiler pools underneath, which were overflowing from broken pipes, as well as water from the firefighters spraying everything. So, and if the lava reached the pools, there was going to be a very significant thermal explosion, which would have dispersed material far worse than even the explosion of the reactor itself blowing up, as well as if it got down far enough, it would actually contaminate the groundwater. So in order to avoid this, they sent volunteers in wetsuits with respirators and flashlights, and they were sent down to open some valves and drain the pools. They were successful. They just took some volunteers that originally they didn't really want to tell them the danger, but they were pretty much like, well, we're not dumb. And so they were told that they were actually told what was going on, and the reason why they needed to do it. And they got some volunteers who were told originally, yeah, you're pretty much just going to die. That's just what's going to happen because of all the radiation exposure. But miraculously, they all survived for a decent bit of time. I believe that one of them died shortly after of an illness that was pretty well linked to the radiation. And then there was the other 2 are actually still alive. They have had some health problems, but they're still alive. So with the pool's gone, the problem now is to keep the lava from melting down through the concrete and the groundwater. So I actually kind of messed up before. It was more just it melting down through after draining the pools and melting down into the groundwater. So there's a picture of them suiting up one of the guys to go down in and turn the valves. So in order to cool the ground, they're originally going to inject liquid nitrogen into the ground to freeze the earth around the bottom of the reactor. But this would have required about 25 tons of liquid nitrogen per day. So they quickly soon realized that it wasn't going to be a viable solution. Instead, coal miners were brought in to excavate a tunnel underneath the reactor to place a heat exchanger underneath the concrete to keep it from melting and keep the groundwater safe. Once the reactor melted and the fuel had been stabilized, they went out about trying to clear the debris from the roof. Several robots were originally tried because the radiation fields were so high they didn't want to send anybody up there, but they all failed due to the high radiation fields. It actually ended up literally burning out all the circuit boards and electronics. Numerous soldiers were brought in instead and were only allowed 40 to 90 seconds, depending on the section of the roof that they were on, to go and clear the debris. So there's pictures of some of the coal miners right there, and there's some of the robots that were used. They actually have them on, they're in a fenced off area. They've been decontaminated, but they still are actually fairly radioactive because they've absorbed so many neutrons and different things. So, but they are there for tourists to see. They just have to remain at safe distance. Each of these bio robots, as they call them, got roughly about 25 rem in that time frame. So from 40 to 90 seconds, they got 25 rem. Once the debris were cleared off the roof, large concrete and steel sarcophagus was constructed over the reactor to seal it off and its contents from the environment. So you kind of heard in that video that they were talking about in a record 200 days, they made this pretty much custom form-fitted sarcophagus to keep things from escaping. There's a lot of people that ended up getting some very high and some lethal exposures in that process. The structure was completed in December of '86, and it was only meant to be a temporary solution. They realized that it wasn't going to last forever, the material that they'd made it out of and everything like that. Once the reactor had been sealed off, they brought in lots of soldiers to act as liquidators, as they were called. The liquidator's job was to go to all the nearby areas and buildings and towns and everything that was around, and go and spray different solutions, and turn dirt over, plow things under, get rid of anything that was pretty much it'd be contaminated or radioactive, and make the areas somewhat safe again. So there's pictures of some of the liquidators. There's the sarcophagus right there, and then there's some of the bio robots that were going and shoveling stuff off the roof. So other soldiers were sent into similar areas to go and dispose of the remaining contaminated pets and livestock in the area. So if you remember, I think his name was Pavel, on the HBO series that depicts and shows them going to the different towns and having to go and put down all the animals and livestock that were in the area, as they had pretty much been consumed or assumed to be all contaminated heavily. So there was lots of impacts from this. There was approximately 38 deaths directly attributed to the nuclear disaster, according to the Soviet Union. However, most experts argue that that is a very inaccurate number. There are around 260 documented cases of acute radiation sickness. After the disaster, there was lots of radionuclides and radioactive iodine that was dispersed around. That has caused a lot of different cancers and cancer deaths. So there's approximately, they're saying, some places were saying around 3,000, a lot around 4,000 deaths due to cancer, but there were some of them that were actually estimating and showing that no, it's all the way up to like 7,000 or 8,000 cancer deaths directly attributed. An interesting fact that I did not know before, following the disaster, doctors gave false advice that most babies would be born with birth defects all throughout the European Union, and the surrounding areas. And so during those few years afterwards, over 1 million wanted abortions happened due to fears resulting from Chernobyl. Essentially, these doctors were like, nope, your baby is going to be born with severe birth defects, Down syndrome, etc. And so there was a lot of people that went and got abortions due to that. And in total, the total estimated cost between everything that approximate cost, not estimated, but approximate cost of cleanup and maintenance of the structure at Chernobyl is said to be about $333 billion total. And they actually have to allot, I believe it's about 10% of Ukraine's budget each year in order to maintain Chernobyl and the areas surrounding it. So what safety culture? There was none. The Soviet nuclear industry was clearly focused on production and cutting costs. They used very cheap reactor design. It was said in some documents that they didn't even bolt the reactor lid down. There was lots of construction problems with the plant. They just kind of looked past as they were trying to hurry and throw it up really fast. They used anything with the reactor was pretty much what can we find and use that is the cheapest, but will still get the job done and still let us be at a high production level. The operators weren't properly trained and were berated for bringing up legitimate safety concerns. Reactors were designed with a known positive void coefficient, which was kept for them kept from the people actually operating the reactors. The reactors also didn't have containment structures around them; they just had buildings. And in any event of an accident, there was a high probability of radioactive release due to that. They knew ahead of time that this test, due to the fact that it wasn't even close to the 700 megawatts that it was supposed to be at, they knew clearly that it wasn't going to yield any valid results at all, but they didn't care. They just wanted to basically say, yeah, we completed the test. That's all they wanted to do. They just wanted to report a completed test. Operators were scolded for not knowing the procedures when they had never seen them before, and were only given a very short time. So they pretty much had to perform on the fly. Another interesting fact is actually that most of the instructions were crossed out due to, they're like, no, we're going to change stuff from before, but they left it all in the same booklet, and so they didn't even know which ones, and some of them had been crossed out multiple times, and so they're like, well, what do we even use? And nobody really knew, so they just went off the best that they knew with that. And then operators knowingly violated numerous procedures and turned off pretty much any and all safety systems, which, yes, for the test they needed to turn off some for it to produce a valid result, but others they completely overrode. For example, turning it off of automatic control, anything like that, ignoring what the computer said to shut down, everything like that, they just bypassed it all. So due to this accident and what had happened, it really shifted public opinion about nuclear power negatively. You still see that even to this day. You can ask anybody, you start mentioning like nuclear power and they're like, oh, Chernobyl or 3 Mile Island, which really wasn't that bad, but you know, this is pretty much the first one that they go to. Oh, Chernobyl. It arguably led to the Soviet Union's collapse, interestingly enough. And it eventually led to safety modifications on the other RBMK reactors, as well as much better procedures on running them, and so that in effort to keep this from ever happening again. So they retrofitted different designs and different things with that. One of the things that they did is they switched to a higher enriched fuel so that it made the reactors at low power much more stable. So workers and management became much more cautious, even in and around the Soviet Union. So they actually started to follow safety protocols and question things a little bit more. And due to this accident, we now better know how radioactive fallout and debris move around, how to manage the health risks from that, as well as what health risks are associated with different levels of exposure. It also halted the licensing and development of new reactors all around the world. There was a lot actually at the time that were starting to start the process of being licensed, and it pretty much just shut all that down. So in the forum, go ahead and post your questions and I'll get them answered quickly. Thank you.